Hello, everyone, and welcome to our 16th online workshop today. And we're going to be spotlighting Jie Ding's lab in Beijing, which explains the slightly dodgy time for people in Europe. I'm Patrick, and I'm a patient and volunteer with Allport UK, and I'm delighted to be back in the hot seat for our workshop today. I'm going to introduce our three speakers from China first. We're delighted to welcome Jie Ding, who has about 30 years experience in the field of pediatric nephrology and has carried out extensive research on Alport syndrome. Through her efforts, there is now a Chinese patient support group to help patients and their families, and Alport syndrome is now recognized as one of the 121 rare diseases in China. Secondly, Dr. Yanqin Zhang, who will present on the diagnosis of Alport syndrome, and lastly, Dr. Fang Wang, and she'll be presenting on the non-invasive monitoring of the progression of Alport syndrome. Wouldn't be able to cover all that alone. No, we have our scientific moderator joining me today, Professor Neil Turner, the Professor of Nephrology at the University of Edinburgh in the UK, and he'll help me put questions to our speakers from the scientific community. Archie Walker and Harriet Carter will run the production of the webinar today, so do message them in chat if you have any problems. Okay, let's make a start to the meat of the workshop. Jie, would you mind sharing your screen and taking us away with the first presentation? And I think you're muted right now. We can see your screen, just can't quite hear you yet. Can't quite hear Jie. If someone could unmute. Oh, there we go. Looks like you're unmuted, Jie.
So now I can start?
Yes, wonderful. Go ahead.
Okay. Hello, everyone. And I will say good morning for our for friends from UK, and good afternoon for my friend from China. And it's a great opportunity to share our research results to all of you. And for my talk, I will briefly introduce about the Alport, the international, and especially in China, what we get on, especially recent years. Because the time is so limited, so my talk is briefly to tell you the whole story. Please see the screen from the very left. You can see actually the first case of Alport syndrome is reported in 1875, long time ago. And I will briefly describe the whole story. You will see the upper part is the story from the international, and the lower part is from China. So we'll see, you will see the first case is a long time ago, it's already described, reported. And later on in 1902, and Guthrie described the hereditary mode is X-linked. And until 1927, Alport, he described the family, and he indicated the features of the disease is abdominal urinary analysis and hearing loss and the progressive renal failure. And in that time, he named that disease is Alport syndrome. It's in 1927. And from that year until now, almost 100 years. And later on, you can see in last century, in 60s, that it's already reviewed the Alport syndrome, the renal pathology changes. And in the last century, 80s, is already a review of found the genetic disorder already discovered the COF4A5 gene, and in 2013 by the Dr. Cliff Cashton, they published the recommendation for the treatment. That's the first international recommendation for Alport syndrome. And in 2020, and the clinical trial, of course, there's other clinical trial in 2000, some years already they started. And that's the international progress for Alport syndrome, roughly. And if you see the lower part, actually the first case of Chinese Alport syndrome until 1978. And the pathology report until 1982, and the genetic report until 1999. And after the international recommendation for Alport syndrome published 5 years later, we published our Chinese recommendation for treatment and the diagnosis for Alport syndrome. And luckily, in 2020, we are in the same time to start the clinical trial, one of the clinical trial, that's the anti-miR-21. So we think we try to catch up the progress of the whole world. So that's the roughly story on the, the path we go through in the last years, several years. And why? And in the rest of the part, I would introduce what's work we done. Especially, I would like to introduce, we set up the Alport registry system. It's in 2012. We set up the registry system. That's the front, the first page of the register system. It's online one. And if you go into the registry, what is look like, and this, it's colorful and a lot of data on this, and some is the clinical parameters, and some is the general informations. And if I summarize that, is the patient information, including general information such as a name, age, gender, etc., and the clinical manifestations and the family history, and the renal pathology, laboratory data, genetic test, treatment, and follow-up as well. So that's all of those information included in the registry system. Unfortunately, that registry system can only be entered by registered doctors, not everyone, because we would like to keep this high quality and for the research purpose. And nowadays, more than 40 centers enroll in that registry system. I'm sorry, I showed those centers' name in Chinese. I didn't translate into English, but anyway, more than 40 centers join that. And those, it is the map of China, so you can see the center distribute the whole of around the whole China. And in that registry system, at first, we enter the data only on Alport syndrome. And later on, we're including more and more hereditary renal disease, such as hereditary tubular disease and proteinuric renal disease, cystic renal disease, and also CACUT. What is CACUT? CACUT is a congenital anomalies of kidney urinary tract. Oh, I'm sorry, tract. I omit that. I'm sorry for that. So it's a CACUT and other hereditary renal disease. Nowadays, all of those diseases enter into the registry system. And I show this factor to tell you And in addition to enter those data in the registry system, and also we keep the patient record in the cabinet, just in case to, to back up that. And also we collected the patient biospecimens, such as urine, serum, and the renal biopsy samples, and also, of course, the DNA in the, refrigerator or freezer, Mm-hmm. And it's not really update, but anyway, you can see for Alport nowadays more than 1,000 families already in our registry system. And the hereditary tubular disease, more than 100 countries, proteinuric renal disease, more than 400, and the cystic renal disease, about 100, and Kakut, more than 200, and some others. And why we set up the registry system, that's why our purpose is to start the clinical and the others research. So I would say what role it play. Of course, we will, by using the registry system, will analyze the correlation of genotype and the phenotype, and also to investigate the biomarkers for predicting outcome, monitoring progression, and detecting disease change sensitivities. Sensitively, I mean, we try to explore some sensitive biomarkers to detect the disease changes. I know Dr. Fang Wang will tell some of those stories in her talk. And also, by using the registry system, we will study the efficacy and the safety of treatments. And we also publish some papers about those kind of the research. And now I give you a brief introduction about our registry system. And later on, I will tell you some about our work between our doctor and the patient. In 2012, we held the first family meeting of Alport Syndrome. And I'm sorry, why is on? And in the first family meeting, there were 76 Alport families participant, more than 100 children and their parents to participate. And we are lucky in the first family meeting, we invite Dr. Cliff Cashton from United States and Daniel Renaud, maybe you know him, he from France, to join our first family meeting. So the photo will show you the first family meeting. So you can see there's a Dr. Cliff Cashton, that's Daniel, and he also joined us. And I know we also get some letters from the United States patient organization. And later on, almost every year, we hold the family meeting of Alport. In 2014, and also the second one, and more families and the children and the parents to join our family meeting. And that's the photo for the second one. It's in 2014, and the third one, and you can see every time we have more and more people to join us. And this gentleman, maybe you know him. He's Mr. Tsai. He is the two Alport children's father. He voluntarily to organize the patient group. And the first one I will address on, because in that time we invite Susie from UK to join our family meeting of Alport. So here is Susie. He gave a lovely talk to all of our patients and also the other important people. And this gentleman is the Rare Disease Association, is the head of the Rare Disease Association in China. He also gave a wonderful talk. And that's the other years. So you can see in 2018 and 2019 every year. And even in last year, 2020, we have a COVID-19, but we still held the family meeting, the parent meet, the family meeting of Alport syndrome. We held that online. I didn't show you the photos, but anyway, we still keep to doing that. And because we work together with the family and the children and their parent. So I think the patient organization, they grew up, they developed very well. For example, they set up their own organization. They call the Chinese Alport Syndrome Parent Association. They set up their website, and also they set up the QQ and APP, all is for Alport. They call it Alport Home. And their theme is, or maybe the slogan is, "Under the blue sky, we are together." So it is very friendly and helpful for every Alport patient. And also the patient organization, the key members try to communicate and exchange ideas internationally. For example, in 2013, and Mr. Kai and to Shanghai to participate in the EPNA Congress, and in 1914, and go to UK, and in 1914, in 1915, he go to, and with the other Alport parent, he went to Germany, and in 2019, maybe you will still remember, we all together go to Italy to join the Alport workshop. So in summary, I will say as the long history for Alport syndrome, our Chinese patient and the doctors, we try to, at the very beginning, we try to follow up the progression of the Alport, whatever is clinical or the research, and we try to catch up the progression. And in recent years, we do our best, try to join or maybe participate in more and more clinical trials, or maybe the other research work. We want to our patient, like the patient in the other country, at the same time to use the new drugs to get the better life. So we'll see, we all working together to reach more. So that's why we would like to also, like today, we have this lab meeting to share you our research work, and the purpose is try to to know each other, and maybe we can work together to get more. So that's all for my today's talk. And this is my team member, most of our team member here, and you can see their lovely smile. And I will say thank you for your listening. Thank you.
Thank you so much, Jie. What a talk. It's so incredible to see this huge patient organization that you've built in China, and also the research that you're doing and the progress that you've made in understanding the disease. I thought the timeline was particularly interesting, actually. I had no idea that the first Allport case appeared in the 19th century. I was wondering, obviously, if anyone else has questions, please do dump them in the Q&A, but I will selfishly work through my own now. I wanted to ask how many patients you've actually got on WeChat now, because this is a huge part of how patients in China communicate. How many patients are actually connected on WeChat?
I think I can generate to answer you as more as possible. You can reach them. Unfortunately, most of them can only use Chinese, so that's why to like a barrier. I mean, the language is a barrier. So we can talk to them freely because they can also typing and speak in Chinese. And I think 杰如叫什么来着？杰如是叫 what her English name?
Sorry?
A Chinese lady. He can speak English frequently. I suddenly
Jessie?
her.
Jessie's,
Jessie.
yeah.
Yeah, Jessie can communicate with you by WeChat. Yeah. Because I can type in Chinese, English, I'm sorry.
I wanted to know how your online meeting went as well. You talked about that online meeting in 2020. Did it go well? Do you have anything to report from that?
Yes, I think it goes very well. That's because we give some education talks, and also we by typing, not really voice communication. The patient asks the questions, and also we answer the questions. So I think the question is quite smart. They ask everything. Some is the drugs, some maybe how to live very well, and some is the others. So I think it's pretty good, because in our clinical practice, if we just see patient in the clinic, usually it's just dealing with the diagnosis and the drugs, how to increase or decrease the amount. But during the parent meeting online, or maybe not online, they ask the questions widely, everything about their life, their daily life. So I think it's wonderful. Yeah.
I think it's always amazed me how intelligent patients with Alport syndrome are about their condition. They really want to know more about their condition. I wondered if patients in China felt the same way about Allport. Allport patients in the UK feel perhaps quite lonely and sad about their condition. I was wondering if you see that in China, if people feel frustrated perhaps about having Allport syndrome.
I think it's the same. I think whatever the patient live in which country, it's the same, especially at the beginning time, they heard the final diagnosis, they feel so frustration. I still remember some of the tears from the parent, also from the elder children. If they are very young, they know nothing, they still so happy because they know what's happened. But when they grow up to the adolescent, especially, they feel so sad. And I still remember one parent tell me, every time he come to my clinic, they won't like to bring the children because the children would like to stay alone. They won't like to see doctor. They won't like to see the other people's. They even don't like to go to school. So I think it's a big problem, not only the physical disease, but also the psychology they need to care. So that's why every parent meeting, we will invite the psychologist to give some talk. We try to help parent and also the children. So in that time, I really would like to ask some question to to the audience from UK. If you are, whatever you are doctor, or maybe you are the patient, how you deal with the disease, if you know you are the Alport syndrome, how to you keep your life and the school life to be normal. So which way is yeah.
I find it very hard because I dealt with my condition almost completely by myself, and I completely relate to Chinese patients feeling isolated or upset because of their condition. And it's really important that these workshops and the online meetings support people absolutely in their mental health. I did want to ask if you'd made any progress with clinical trials. So you talked about a little bit about your 2020 trials. Have you got to the stage where you can share research yet, or is it still in the early stages?
Okay, maybe I can share a little bit about this newly started clinical trial. You know, let me, I will say a little bit surprised, you know, when we enroll the patient. Before I think our patient would like to participate. When we really screen the patient, I feel, why I say I surprised, because they are so lovely to join the clinical trial. You know, that's make me so, you know, I feel so how to say, so touched, because they really like to get the new drug, whatever they know, because we tell them maybe you are randomly to, you know, to the placebo group, they think okay. And you know, this clinical trial, they will visit every week, you know, and also the enrolled patient is older, 18 years old, so they either in the school or maybe in the college or maybe already work. So every week they come to the hospital. You know, this is so hard, but they still keep to that. I think Dr. Wang will know that, because almost every week they will, you know, to see the patient. So I think is although pretty hard, they still keep doing that. So that means they are willing to, you know, to have the new drugs. So I think it's very brave and encourage us. And so in that way, we enroll patients pretty quick. From the pharmaceutical people, they tell us, oh, they don't believe in China we enroll patients in that such a short time. All of them already come here. So nowadays, recent days, we apply to enroll more patients. Now already get approved.
Fantastic. I mean, Allport patients are always very impressive. I think we're very used to lots of hospital visits and that sort of thing. I want to turn over to Neil now, who I hope will have some questions from the scientific community. Neil.
Allport patients sure are, Patrick. I would completely agree with that. Jai, I thought it would be interesting for the audience to hear a little bit about what it's like to be an Allport patient in China. And that's tricky because I appreciate that you're a pediatric unit, which is going to be a bit different. And you're also in Beijing, where I think is probably the top end of what is available. But we need to remember that China is 3 or 4 times as big as the United States and twice as big as Europe, and clearly there's a lot of regional variation. And I was wondering what services are like, you know, how easy is it to get even routine medicines and your blood pressure and urine checks if you're 1,000 miles away from Beijing? Clearly the people who can visit you are very lucky.
It's a good question. It's a practical question. Yes, of course, China is so big. So not every patient should come to Beijing to visit to see doctors. Actually, maybe I will say in 20 years ago, and I think only Beijing, or maybe most you know, the doctors, they know how to treat, how to diagnose Alport syndrome in Beijing. But nowadays, by the CME, we already train more and more doctors. They know how to diagnose and treat Alport syndrome. And especially after we publish our recommendations for diagnosis and treatment for Alport syndrome, I think more and more doctors know how to deal with the Alport syndrome. In the other way, I think for the patient organization, now not only Mr. Tsai, the organization guided by Mr. Tsai, and also he want to distribute his ideas, his experience in the other provinces and the cities. For example, as you know, in the end of the February is International Rare Days. So now more and more activities around those days. So we can, from the WeChat or maybe the other media, we know in China more than one Alport parent meeting held recently. So I would say I try to briefly answer your question. Not every people should come to Beijing.
No, no, they can't. And I was wondering, really a follow-on from that is the patients in the registry, are they mostly around Beijing or are they further flung? And there's a sort of follow-on from that, which is how easy it is to get follow-up data on patients in, you know, rather different healthcare regions and so on.
Yeah. Anyway, follow-up is so hard. Even they just live in Beijing because you know, for every reason, maybe so busy and ashamed, or they ignore for that. So follow-up is so hard. But anyway, I think follow-up those patients, especially in our registry system, is all over the whole country. So that's why we have more than 40 centers. These centers distribute all of the China, so they can follow up the patient and then to entry the data in the same system.
It's worth remembering that you have 40 centers to cover China. I think the UK has bigger renal units than most countries, but we have 75. Wow. 75 for a population of 70 million. And yeah, but it's just fantastic to see the progress you're making. Actually, so I was lucky enough to visit Beijing when Professor Fang Wang took us round to some places, and the standard of care was very impressive in Beijing, but the further you went from Beijing, the thinner the facilities were. And I was wondering how easy it would be to follow up an Allport patient there. But that was, I think things were clearly improving very fast, and I'm sure things have moved on further again. So thank you very much.
Thank you for your question. Thank you.
Okay, fantastic. Thank you so much, Jai. I think we better move on to our second presentation in the interest of time. Yanqin, would you mind sharing your screen and taking us away?
Okay.
Thank you very much. I'm seeing an interesting discussion going on in chat right now as well. Oh, that's me.
Can you see this right?
There we go. Yeah, we can see the presentation. Fantastic.
Okay.
When you're ready, go ahead.
Okay, thank you. Good morning and good afternoon, everyone. I'm glad to talk about. I'm glad to have the opportunity to talk about diagnosis of Alport syndrome. Professor Ding has talked about the history of Alport syndrome, including the diagnosis history of Alport syndrome. And so I want to go into the detail. Now we include the diagnosis of Alport syndrome. We can include clinical diagnosis, pathological diagnosis, and nowadays genetic diagnosis. And now what we are trying to do is early and correct diagnosis, making early and correct diagnosis for Alport patients, because it is crucial for patients to receive early and effective treatment. However, the genotypic and phenotypic complexity of the disease of Alport syndrome may delay the process of achieving early diagnosis. So this is the outline of my content. First, diagnosis of Alport syndrome in China. Here is a picture. We can see the mean time from onset of disease to diagnosis of Alport syndrome in China is decreasing from over 50 months in 1995 and to about 30 months in 2015, and it decreased to about 20 months in 2017. And we should know this time depends on whether the patient go to the doctor immediately when he found abnormality in his urine. Because some patients, they don't pay attention to the urine test and they neglect it, or so it may delay the diagnosis. We analyzed the patients who diagnosed as Alport syndrome in our hospital in the last 5 years. The mean time from the first visit to diagnosis of Alport syndrome in our hospital was about 3.5 months. Compared with the data published in 2015 by our center, the diagnosis method have changed within the last 5 years. The percent of patients who diagnosed by skin biopsy or kidney biopsy declined, and the percent of patients who diagnosed with by gene test increased. As gene test applied in more and more patients, we should pay attention to some special cases. Here I'd like to, I have 3 cases share with you. The first case is a 10-year-old boy. He had hematuria and proteinuria for 3 years, and he had normal kidney function and no hearing loss and ocular lesions, with no family history of kidney disease. And the quality 4 alpha-5 chain staining in the epidermal basement membrane of skin was negative, and he underwent kidney biopsy, and irregular thinning and thickening and splitting of glomerular basement membrane by electron microscopy was detected, and he was diagnosed as X-linked Alport syndrome. However, the no pathogenic mutation of Alport genes by next generation sequencing were found for this patient. Then we extract mRNA from his skin fibroblasts and analyzed COFA-A5 gene, and we found a de novo mutation in COFA-A5 gene. It was a splicing mutation, and then we detected the COL4A5 gene on genomic DNA of the patient, and we found a deep intronic variant in intron 25. And so this patient was diagnosed, confirmed with genetic diagnosis of X-linked Alport syndrome. And the second case is a 26-year-old girl. She had hematuria and proteinuria for about 2 years, and his renal function declined, and she had no hearing loss and ocular lesions. Her father had hematuria and normal kidney function, and her mother and sister had a normal urine. She underwent renal biopsy, and irregular thinning and thickening and splitting of GBM was detected by electron microscopy. And she was diagnosed as Alport syndrome, but the inheritance pattern was unknown. After gene test, no pathogenic mutation was detected. For this patient, we extract mRNA from urine, and we analyzed the 3 Alport genes, and we found 3 pathogenic splicing variants in COL4A4 gene. And also we found deep intronic variants in COL4A4 gene on genomic DNA of the patient. And 2 of the variants were inherited from her mother, and the other variant inherited from her father. So this patient was diagnosed as autosomal recessive Alport syndrome, finally. The last case is a 13-year-old female. She had renal dysplasia, and her serum creatinine concentration increased, and she had no family history of kidney disease. After next generation sequencing, she found homozygous deletion of exon 1 to 20 of NPHP1 gene, and a missense variant in COL4A5 gene. It's a glycine substitution. Both her parents were heterozygous carriers of the deletion of exon 1 to 20 in NPHP1 gene, and the variant in COL4A5 was inherited from her father. So the patient was diagnosed as nephrolophthisis type 1, and we want to know whether she should be diagnosed as Alport syndrome. So let's see the clinical information of her father, who also had this missense variant in COL4A5 gene. Her father was 42 years old with normal urine and kidney function. And so her father had no clinical traits of Alport syndrome. Then we searched this missense variant in the database, and we find this missense variant was reported as pathogenic before, but it had a high frequency high allele frequency, about 100% in population. So we searched our registry database, and we found 36 individuals with this missense variant from 19 families, and we analyzed the individuals with only this missense variant and the clinical characteristics, and we find there are two fathers aged 42 and 35. They had no clinical traits of Alport syndrome at all. And the other individuals with only this variant also can't be, no one should be diagnosed as Alport syndrome. So we concluded X-linked individuals shouldn't be diagnosed as X-linked Alport syndrome, only based on the detection of this missense variant in COL4A5 gene. So I want to share the information here. Clinical manifestations are the basis of diagnosis of Alport syndrome. And second, for patients with negative next generation sequencing results, mRNA analysis of Alport genes from urine or skin fibroblasts can be helpful to make genetic diagnosis. And we recommend analyzing Alport genes from urine mRNA as the first choice, for it is non-invasive. Thank you for your attention.
Thank you so much for another fascinating presentation. It was really interesting to me that Chinese doctors are facing the same issues with diagnosing the disease as the ones in the UK. Also really exciting to see the drop in the prevalence of biopsies. I think most patients that have had a biopsy will tell you it's a very unpleasant thing for a patient to go through, right?
Yes.
I was wondering how patients in rural areas actually get the diagnosis of Alport syndrome. Is it more challenging than in the city? What's the process there?
You mean the patients from rural area?
Yeah, from the countryside where there isn't a lot of renal clinics.
Yes, yes. I think the patients from rural area has less opportunity to know the abnormality in their urine. Mm-hmm. So maybe some patients only have other disease, and they went to the hospital for like some patients they need to do surgery, have surgery. Mm-hmm. Then they will, before the surgery, the doctor will test the urine, and then they may find the abnormality. Yes, but I think there are still many patients with Alport syndrome they don't know.
What's the initial treatment for children diagnosed with Alport syndrome in China? What drug would you recommend? What drugs would you recommend?
In our center, we recommend ACE inhibitor first. I think in other hospitals recently, they after we published the recommendation for treatment recommendation for Alport syndrome in Chinese. The doctors can read and they know ACE inhibitor first for Alport syndrome.
Fantastic. Well, that's really great news to hear. Neil, I'm sure you have a few questions too.
I was going to pick up a little bit on the really interesting and difficult questions of the patients where you don't pick up the abnormality on ordinary gene sequencing. Francis Flinter has raised the question of whether you ever use hair roots, with which rather than a skin biopsy, with which I think you can look at, you can certainly look at alpha 5 that way, but maybe it doesn't have alpha 3 and 4.
Yes, but hair roots, we has tried this method for some patients. For some patients, we think they are they has tissue mosaic. Am I right? The different the mutation in yes, the percent of mutation are different in different tissues. So for these patients, we tried hair roots and urine, mRNA or many tissues. I wanted to explain why we use skin fibroblast mRNA for some patients, because in China, some patients before the gene test, before I think maybe 3 years before the gene test, almost take time, about 3 months, and when the patient come here, they want to know the diagnosis as soon as possible. So skin biopsy is compared with the kidney biopsy, it's less invasive damage, so they can accept this. So we have some patients choose skin biopsy, this test, to make diagnosis. So we have the skin fibroblast, and I think it is useful for the patient, especially after next generation sequencing, they found no pathogenic mutation. The skin fibroblast is very helpful.
One thing I'm not very familiar with being used in the UK at all is urine samples, and I wonder how reliable it is to get positive PCRs for Allport molecules from urine.
We recently we have done about 10 cases. We use this method, make a gene diagnosis, about 10 cases, and all of these cases were diagnosed as Alport syndrome clinically or pathogenically, but they didn't find pathogenic mutation by next generation sequencing. And we analyze Alport genes using urine mRNA, and we find the pathogenic variants for them. I think that it's reliable, and it's easy to collect sample.
You get all 3 genes that way, or mRNAs that way, which is yeah, that sounds good. Particularly if their podocytes are falling off into their urine. Yeah, that sounds good.
Yes.
I think it's really extraordinary how quickly technology is moving on, and the ability to look and see the intronic mutations moving on as well. Are you doing this through whole genome sequencing, or are you targeting the gene for an intensive PCR approach?
We in PCR approach, but we will when we found the abnormal splicing variant in mRNA, we will do PCR on genomic DNA and covering very large fragment.
Clearly, the last thing I wanted to say was it was really interesting to see another example of two diseases together on your list, or possibly two diseases together with the nephronophthosis and an Allport mutation. And it is with whole genome sequencing, I guess, that we're going to be confronted with a lot of this and a huge number of questions over the next decade. And thank you very much. Fascinating to see.
Thank you.
Fantastic. Thank you both so much. We move on now to our final presentation. Dr. Fang Wang, would you mind sharing your screen and kicking off the final part of the workshop? Looks like we can see it. Fantastic. Are you there? Not sure if we can hear you yet. Can't quite hear you yet. Although we can see the presentation.
Okay.
Okay, brilliant. Whenever you're ready.
Yeah. Okay. Yeah. Can I begin? Okay. Hello, everyone. I'm glad to have a chance to share with you about our team published studies. As we know, Alport syndrome is a result of mutations in one of these three genes, and abnormal type 4 collates of 3, 4, and 5 originates only from podocyte. This disease is a major cause of renal failure, developing before 30 years old. In the clinical settings, proteinuria and renal function are often used as biomarkers to predict disease progression. However, they are imprecise and insensitive. This disease severity is primarily caused by the patients and their families. The question faced by clinicians is that whether it is possible to non-invasive monitor disease progression more sensitively and accurately. To answer this question, we performed two studies. The first one was about urine podocyte detachment rate in Alport syndrome. The enrolled Alport patients was divided into 4 groups, presented with only with hematuria, microalbuminuria, proteinuria, and massive proteinuria. The left and the right finger should use different methods to detect urine podocyte detachment rate. We can see from these 2 fingers compared with control, urine podocyte detachment rate measured as podocin MRA in Alport syndrome patients with hematuria was significantly increased. The result means increased podocyte detachment in the urine pellet occurrence prior to amenable increase in either proteinuria or microalbuminuria. The left finger showed there was a linear relationship between age and podocyte number per tuft for Alport syndrome with different level of proteinuria. And the right finger showed there was a reasonable correspondence between the average, just this line, the average projected podocyte number based on the urine podocyte detachment rate, and the observed values just showed circle in Alport syndrome biopsy. This slide showed the relationship between podocyte depletion in renal tissues and the clinical parameters, such as proteinuria and renal function. We can see from the these 4 fingers, both proteinuria and decreased renal function expressed as estimated glomerular filtration rate were associated with podocyte depletion, measured as podocyte number per glomerular or GLP-1 area density. These 2 fingers showed the relationship between podocyte depletion in renal tissues with glomerular sclerosis. We can see that podocyte depletion in renal tissues was associated with glomerular sclerosis. So from the study, we can draw the conclusion compared with proteinuria and serum creatinine, non-invasive urine podocyte detachment rate can be used to monitor sensitively altered renal function in patients with Alport syndrome, and it could potentially help to predict time to end-stage renal disease and response to treatment. The following study was about urine epidermal growth factor in Alport syndrome. In this study, we enrolled healthy children and Alport syndrome children. The left finger showed, compared with healthy children, just showed the blue color. Overall, or in each individual age group, urine EGF levels were lower, just show the red color in Alport syndrome children. The right finger showed with age increased, urine EGF level decreased in both healthy children and Alport syndrome children. However, compared with healthy children from the same age group, urine EGF level in Alport syndrome children, we can see fell faster. This slide showed urine EGF level is significantly and positively correlated with the rate of estimated glomerular filtration rate change over years. From the red circle indicated the progressive group, and the dark indicate non-progressive group. For the progressive group, we means during about 2 years of follow-up, the patient chronic kidney disease stage advanced. This slide showed the same phenomena. That means among patients with EGF more than 60 and lower urine EGF level and baseline, this group included 27 children. 70% of them had advanced CKD stage during 2 years of follow-up. And among 9 children with EGFR more than 60 and normal urine EGF level at baseline, no progression was observed during 2 years of follow-up. We can draw the conclusion from this study. The non-invasive urine epidermal growth factor 2 creatinine ratio can be used as a predictive marker for the progression of renal function in children with Alport syndrome. It is useful to early identify the children at high risk of disease progression. Although the results of these 2 studies are exciting, to validate the value of urine podocyte detachment rate and the epidermal growth factor to creatinine ratio in Alport syndrome, prospectively study includes more patients and a longer follow-up is required. Thanks for the support from grants of China, my colleagues, patients, and their families. Thanks for listening. That's all.
Thank you so much, Fang. A patient talking in one of our private chats had a really interesting point that Allport patients are typically very young, so blood testing them all the time with needles is, I think, quite a stressful process for them. It's really good to see that urine tests are also very indicative of disease progression. Would you recommend testing both the blood and the urine of a patient at the same time, or is it enough now to simply test the urine to measure progression of the disease?
Depend on if the patient in out clinic service usually we collect urine, but for patients in hospital hospitalized, maybe we collect blood and urine at the same time.
Yeah, I guess that makes sense.
Yeah, okay.
Having been in hospitals, I understand that the frequency of blood tests is very important.
Yeah.
Something that someone else noted was this also gives the opportunity for early diagnosis,
Yeah.
or at least early diagnosis of a kidney condition, and that presumably helps a lot with treating them as well.
Yes. Yes.
And knowing when to up certain medication, all that sort of thing.
Pardon me?
And knowing when to change medication, that sort of thing.
The question is about whether we will, according to the results of urine, we treat the medicine.
Yeah.
No, until now, these two studies only performed in the lab, cannot routinely performed in clinical service. So yeah, we usually still use protein and renal function as biomarkers for to decide whether we will treat the dose of medicine.
Well, thank you very much. I'm going to turn it over to Neil now to help break
no.
down a very interesting talk.
Yeah.
Thanks very much, Fang. It's very, but both of those tests you've used are really interesting in understanding what's going on, and maybe particularly, and it's worth saying, isn't it, because that both of these tests work in other diseases too. And that is very helpful potentially, because if you think that the test is telling you something about the cause, like the podocytes falling off, if that's the cause of the glomeruli getting more sclerosed and seizing up, then preventing that and lowering that test result would be a good thing. And actually there's a lot of evidence that podocytes falling off is a bad thing. I wonder if everyone remembers that the glomerular filter, this very beautiful structure, is very dependent on the so-called podocyte, podocyte meaning foot, podo, and it has these beautiful processes. And as the structure of those processes is lost, you tend to leak protein and your glomerulus tends to fall apart. So not surprisingly then, finding lots of podocytes in your urine, as reflected by your nephrin PCR test, is a bad thing. And anything that stopped that from happening might be a good thing. It's not come into general clinical use, that test, because getting RNA out of urine isn't a simple technique that's ever going to be very easy to apply outside research studies, but it's really interesting. The second one, the EGF in urine, which again has been shown in a number of kidney diseases to be a sign of a good prognosis. The more you have, the better. That's produced by not the podocytes, well, maybe a bit by the podocytes. Most of that comes from the general tubular cells in the kidney. And I guess it's just a reflection that they're healthy. If they're producing a lot of EGF, they're healthy. And maybe this is a more downstream marker of how the kidneys are doing. Again, it's interesting that it hasn't yet come into clinical use as a test that's going to alter treatment and so on. And I think maybe the problem is that when looked at in an individual patient, the values are a little bit more difficult to interpret with regard to whether or not that patient has a good prognosis or not. It's only when you look at tens or hundreds of patients that the strong relationship comes out. And I think the other downside with using it as a general clinical marker yet, but I have to say I'm quite hopeful about this as a very early marker in the future. But at the moment, a little while after, in most of these patients, they're going to develop proteinuria, which we have very cheap, very widely used tests for already, and which, for instance, we use as a marker of when to start ACE inhibitors. So I think if I was going to come back, Fang, and ask where you see this test being used, I mean, at the moment, if someone comes from a family with Alport syndrome towards the early end of the spectrum, you know, more quite, say they have a mutation that's a gene deletion, it's quite likely to be early onset. We're already starting treatment very soon, as early as we can. The slightest hint will put them on an ACE inhibitor. The population where we aren't sure is where the mutations are milder or possibly milder, or in women who have one mutation, one mutated gene, one normal gene, and you're wondering what the long-term prognosis of them is when you can start treatment. Do you think this test is going to become useful, or do we need something else as well?
I think, you know, for just you mentioned for urine EGF, maybe I think the marker may be combined with proteinuria and renal function together to help doctors to help doctors whether we should change our decision. But you know, the sample is small, so I think, yeah, although the result the value of EGF in adult CKD is definitely clear, but I think for children, there are a long way to go.
Yeah, I mean, I do think that it's just worth saying this is not a PCR test. It's an easier test to do. It's a lot more expensive, I imagine, than measuring proteinuria, though. But in selected patients where you're worried about it, it might well be a test of the future. And it's really interesting to see those results. Thank you.
Thank you, everyone, for coming today. Thank you to our panelists. And thank you particularly to the Chinese patient organizations. Mr. Tai is an incredibly inspirational figure for those of us in the UK. The scale that we're seeing in China, the organization, the patient interest, it's so exciting to see. And we can't wait to engage with you more through online and physical workshops over the next year. Our workshops this coming year will feature amazing research from others around the world. Firstly, Laura Perrin's lab in Los Angeles. This is the next talk. They're on the west coast of the US and their lab are working on stem cell therapy ideas. We're very excited to have that workshop coming soon. And of course, Alessandra Ranieri's lab in Siena, Italy. They're working on genetics, gene therapy, and COVID-specific research. And finally, Marita Barua's lab in Canada, and they'll be joining us again in July for, I think, their third appearance to update us on their lab's research, where they're trying to improve diagnosis by looking at the relationship between FSGS and Alport syndrome. A huge thank you to Jie, Yanqin, and Fang, and of course to our wonderful moderator, Neil, who keeps coming back. It's very generous of all of you to share your time with us today. Finally, a huge thank you to Kidney Research UK for your sponsorship. You help fund our Zoom subscription and, of course, keeping these workshops going. If you have any feedback about this session or want to be added to our mailing list, email research@allport.info. Patients can join the Allport Warriors Facebook group, and anyone can hit us up on our Twitter and Instagrams. That's @Allport UK. We're really pushing the Instagram, so do join if you can. We'll get a recording of this talk up on YouTube in a few days' time. Otherwise, thank you all so much for watching and have a lovely rest of the evening, morning, day, wherever you're tuning in from. It's a goodbye from me.